Hello, everyone. Welcome to Backyard Musings, broadcasting live from Apple Valley. I'm Steve.
I'm Scott.
Thank you for joining us today. Today is Scott's favorite subject, Pluto. We are talking about Pluto today.
We're going to talk about the planets. I love to talk about Pluto, the forgotten planet. So, yep,
Yep. And
cool story.
interesting on this slide, if you look at the bottom center, that's an interesting photo from a spacecraft. And it says in the caption there, I can't read it, it's way too small. But that is the nothing is disjointed. That's the actual shot. That's how close Charon is to Pluto, and they're forever tidally locked. So they're always facing each other. They never rotate away from each other.
Yeah,
So they're like
that's
doing
right.
this. It's
That's
fascinating.
anti-normal gravity and rotation of the planets and the moon. So,
Yeah, I tell you, if something happened to our moon, like an explosion or something like that, and it pushed closer to our Earth, it would be the same thing. We'd be tidally locked with we wouldn't be rotating, we'd be just doing this thing. It'd be crazy. All right. Pluto and Charon's original story. Now, Charon is from the guy that lets people across the river Styx into Hades in not Roman, but Greek mythology.
okay.
Yeah. Pluto and Charon's origin story has been rewritten by a recent study revealing they formed from a unique kiss and capture collision that defies traditional scientific theories. This discovery, emphasizing the structural integrity of icy worlds, may illuminate new pathways for understanding planetary formation and evolution. These findings were published on January 6th in the journal Nature Geoscience. Would you like to know more?
Okay, so here we go. We're talking about a planet that forever was considered a planet, and then a few years ago,
Got
somebody decided
canceled.
to say it's not a planet.
Yeah,
Well,
it got canceled. Poor
yeah,
Pluto.
I don't go for that. So anyway, billions of years ago, in the cold expanse of the outer solar system, two icy worlds collided. Instead of obliterating each other in a catastrophic impact, they briefly fused. Fascinating, spinning together like a celestial snowman. Uh, yeah, nice thought there. Eventually, they separated but remained forever bound in orbit. This dramatic encounter explains the origins of Pluto and its largest moon, Charon. According to a new study from the University of Arizona, which challenges long held scientific theories, led by Adine Denton, a NASA postdoctoral fellow at the University of Arizona's Lunar and Planetary Laboratory. The study uncovers a surprising kiss and capture mechanism. This newly identified process sheds light on how planetary bodies form and evolve. By accounting for a critical but overlooked factor, the structural strength of icy worlds, the researchers have revealed an entirely novel type of cosmic collision. So
Just
that's
want to point out this researcher, University of Arizona, she's a wildcat, not a Sun Devil.
yeah,
Sun Devils are Arizona State.
yeah. This is your state
Yeah.
emissary, right?
Well,
Kind of.
nah. She's a wildcat. Okay.
But I'm just saying the schools they're rivals.
Yeah, they're rivals,
Like
definitely.
kind of like USC and UCLA or
Yeah.
University of Washington, Washington State.
BYU and Utah State.
Yeah,
Or University of
or
Utah.
University of Utah,
Yeah.
or
All right. Go ahead.
or UVU.
Yeah. All right. For decades, scientists have theorized that Pluto's unusually large moon, Charon, formed through a process similar to Earth's moon, which we reported on that last year, a massive collision followed by the stretching and deformation of fluid like bodies, Denton said. This model worked well for the Earth moon system, where the intense heat and larger masses involved meant the colliding bodies had behaved more like fluids. However, when applied to the smaller, colder Pluto Charon system, this approach overlooked a crucial factor: the structural integrity of rock and ice. Pluto and Charon are different. They're smaller, colder, and made primarily of rock and ice. When we accounted for the actual strength of these materials, we discovered something completely unexpected, Denton said.
So this kiss and capture, right? Is that what it was called? Kiss and
Yeah,
capture.
yeah,
So that's not like. So they're both similar in body and mass, right?
yes.
That's interesting because I know.
And rock and ice. It's so cold out there. It wasn't. You didn't have like liquid. To it's different. Rock and ice is different than fluid movement.
Yeah, but I'm just trying to think. So when they collided, I
Boom.
guess ice will adhere to ice, right? I mean, I'm thinking about the old, when you stick your tongue or your lips on a cold pole. Uh,
Yeah,
they they
don't do that
they
for our
fuse.
viewers. Don't do that
Yeah,
because you'll.
yeah, exactly. They fuse together. Just
Yeah,
watch Christmas Story if you want to find out
yeah,
how that.
yeah,
But so cold to cold, I guess would do the same thing then, right? So interesting.
yeah,
My
yeah.
my weird analogy. So all right, so I'm using advanced impact simulations on the U of A's high performance computing cluster.
Which probably involved an AI chip, right? Okay.
Yeah, of course. The research team found that instead of stretching like silly putty during the collision, Pluto and the proton Charon actually became temporarily stuck together, like I was just talking about, rotating at a single snowman shaped object before separating into the binary system we observe today. A binary system occurs when two celestial bodies orbit around a common center of mass, much like two figure skaters spinning while holding hands.
Now, who would have thought that as Pluto as a binary system? Nobody said Pluto and Charon. People talk about Pluto. You know,
Right.
this
Yeah, I
is
don't ever,
completely fascinating.
I've never heard of this Charon until now. So,
Yeah, yeah, fascinating. And you can see on the slide, Pluto has four moons that we know of. Charon being the big one, and the ones named after Greek. Nyx, Styx,
which
Hydra, and I can't read that other one. I can't read
Well,
it.
which comes back to the same thing I was talking about. If you're a planet, if you're not a planet, how can you have a moon? Wouldn't it just be another, what do they call it? Like an asteroid or mass floating around in space, a star. It's a
Yeah.
planet.
So Mars has a moon. I
Uh,
don't know that Mercury has a moon. I don't know that Venus has a moon. I don't know. I just have to look into that.
But those are all considered planets.
They are. But you said, how can it be a planet without moons?
Or how can it be a planet if it has moons? They're saying that it has moons
Right.
more than Charon. So anyway,
Yeah.
I don't want to get off on that tangent. So
Yeah.
we
We don't want to trigger Scott this morning.
yeah, no, it's
Yeah.
not something.
Yeah.
You were
He hasn't had his hot cocoa yet.
right.
All right. Quote, most planetary collision scenarios are classified as hit and run or graze and merge. What we've discovered is something entirely different, a kiss and capture scenario where the bodies collide, stick together briefly, and then separate while remaining gravitationally bound, said Denton. Just like when we said they're tidally locked, they facing each other. Um, when they rotate, they're not rotating away from each other. They're rotating like this, around each other. The compelling thing about the study is that the model parameters that work to capture Charon end up putting it in the right orbit. You get two things right for the price of one, said senior study author Eric Osfaug, a professor in the Lunar and Planetary Laboratory.
Yeah, so if you're on one of these planets, a moon or the planet, all you're going to see is the same face of whatever you're looking at.
The same face. Yep, that's correct.
Interesting. All right, so the study also suggests that both Pluto and Charon remain largely intact during their. That's another fascinating thing, which with much of their original composition preserved. This challenges previous models that suggested extensive deformation and mixing during the impact, Denton said. Additionally, the collision process, including tidal friction as the bodies separated, deposited considerable internal heat into both bodies, which may provide a mechanism for Pluto to develop a subsurface ocean without requiring formation in the more radioactive, very early solar system. timing constraint that has troubled planetary scientists.
Yeah, that's an interesting thought right there. I mean, that's deep into planetary studies, but it's very interesting.
Yeah, so when they collided, that had to cause some kind of um,
Friction.
earthquake or friction. Or I
Oh,
mean,
yeah, definitely earthquakes.
they just didn't dock like you would dock a spacecraft or something like that.
No,
They bumped pretty good. So
probably
uh,
killed everything on the planet, whatever was on the planet.
yeah,
Yeah.
okay.
Okay, the research team is already planning follow up studies to explore several key areas. The team wants to investigate how tidal forces influence Pluto and Charon's early evolution when they were much closer together, analyze how this formation scenario aligns with Pluto's current geological features, and examine whether similar processes could explain the formation of other binary systems. Quote, we're particularly interested in understanding how this initial configuration affects Pluto's geological evolution, end quote, Denton said. The heat from the impact and subsequent tidal forces could have played a crucial role in shaping the features we see on Pluto's surface today. And it's not like we need a very powerful telescope to see it. We need like a Voyager spacecraft to be rotating about it and studying it, high res photos.
Now, what was that other telescope that was launched as a satellite? What was that called?
Uh, I know what you're talking. Weber? Is it Weber?
Nah, I thought it started with an H.
Hmm.
I don't know. I'll think of that. My mind is old and tired. So, but yeah, that. Oh, Hubble, the Hubble
Hubble.
telescope.
Hubble.
Yeah.
Yeah, that's in orbit. Yeah, definitely in orbit.
So, and that's kind of cool. So, I mean, I imagine they're still using that. I would think, but
Yeah. Yeah.
I'm glad the current issue or the current interest in Pluto's shape. I like this. For
Yeah.
being.
We need to get eyes on the target, get something out there, launch something so it can study it. Every single planet in our system.
Yeah, it's far enough out there to where I don't know if I would be able to, as old as I am, or as old as some of the people that are working on this kind of stuff, would be able to see the fruits of their labors. But I think it would be cool if they did. I mean, there's other planets out there, obviously, that we're studying, and they're getting back data like we talked about a few days ago. But this is cool. I like Pluto.
Totally cool.
I'm a Pluto guy.
When I saw this article, I thought, man, Scott's going to get excited.
Yeah, this is cool stuff. So, all right.
All
Thanks,
right,
everyone.
folks. Thanks for joining us. We'll see you in the morning.
Take care, everyone. Thank you.
Okay, I'll pop out and then reinvite you.
All right. Thanks.